Hello, we are still working on chapter R. This is a review, and we are on section R.2. Let's have a look at set builder notation on your textbook, page 6. And set builder notation is this kind of notation here. This kind of thing, where you're gonna have the braces, and inside the braces, usually you represent a set inside the braces like this, right? 1, 2, 3, and on. And the set builder notation is actually building a set by opening here the braces, and you write x or any variable x such that x, and then you explain what you want about x. X is an odd number between 0 and 8. X is a vowel between A and A, B, C, and D. Whatever. If you explain here what's going to be your set, then you're going to have your set builder notation. And actually, the most usual way you're going to find this is by having inequalities. So you have your set builder notation, let's say braces, right? X such that x is less than 3, and then you're defining here a set of real numbers where x is equivalent to all the real numbers less than 3. Another set, let's say here x such that x is greater or equal than 100. So this is x is equivalent to all the real numbers which are greater or equal than 100. So you're defining with set builder notation, you are defining the set of numbers corresponding to the variable that you specify here. In this case, we are working with x. Let's give you another example. X such that x equal to 1 or x equals to 3. So this is another set of numbers which is actually equal to 1 and 3, right? Let's see here some examples on how to use set builder notation. First one, set of vowels in the English alphabet. So this is the first answer here. X such that x is a vowel in the English alphabet. Second one, set of odd numbers between 0 and 8. The second example here, x such that x is an odd number between 0 and 8. Third example, set of real numbers greater than 10, not including 10. Let's write down here, braces, x such that x is greater than 10, not including 10. This is number 3. And number 4, set of real numbers less or equal than 10, including 10. X such that x is less or equal than 10. When you say less or equal, you are including 10. Let's work on some practice now, and this is for you to work. Answer these questions here. Pause the video, answer the questions, and then after you finish, you play the video again so you can check it out. We're back, and let's go to letter A. Letter A. Oops. A. X such that x is greater or equal than 3. So first draw the number line. Always represent the arrows. That means this side goes all the way to infinity, and that, the left hand side, goes all the way to negative infinity. And here in the middle, 0. And x is greater or equal than 3. 1, 2, 3 to the right, because it's positive, right? 3. And everything that's greater than 3 is in the set, is included in the set. And is 3, the point 3, included or not included? See, there's an equal. Yes, it is included. So bracket, square bracket, to represent that 3 is included. And the interval notation for this is going to be, bracket 3, comma, infinity, parentheses. This is the interval notation. Next one, letter B. Go draw the number line, and now we want to represent P such that P is greater than 3. So infinity, negative infinity, 0, and 1, 2, 3, the same. Now P is everything greater than 3. Greater than 3 is represented here on the right hand side of 3, and this inequality here, 3 is not included, so we will represent with a parenthesis. And the interval notation representation is parenthesis 3, comma, infinity. Nicely done. Let's move on. Now something that looks complicated, but is actually quite easy. Translation into math. We learned on table R1, and table R1 is this one here. This is table R1. When you have this symbol of inequality, you can translate by A is less than B, or B exceeds A, or B is greater than A. And you also, another thing that you sometimes you need to do when you have a math problem is translate from these words here into math. Now we are translating math into words, and sometimes you have to translate from words to math, and that's what we're gonna do right here. A tropical storm is updated to hurricane status if the sustained wind speed W is at least 74 miles per hour. So focus on the words that are important here. W is at least 74 miles per hour. Forget about the rest. So W is at least. What means at least? It's the minimum value, right? So W is going to be greater or equal than 74 miles per hour. Hurricanes, next one, letter B. Hurricanes are categorized according to intensity by the Saffir-Simpson scale. On a scale of 1 to 5, a category 5 hurricane is the most destructive. A category 5 hurricane has sustained winds W exceeding 155 miles per hour. So focus on the words that are important here and forget all the rest. So W, exceeding, that means is greater than 155 miles per hour. And that's how you translate from words to math. And the last one here, category 4 hurricane has sustained winds, W of at least 131 miles per hour, but no more than 155 miles per hour. How do we represent this? So W is going to be between 131 and 155. Is at least 131. So it can be equal to 131, and 131 is less or equal than W, right? But no more is no more, but can be equal, less or equal than 155 miles per hour. That's it. That's how you do the reverse. You translate from words into math. And we conclude here this section, and now you have the activity. You have this activity, inequalities and interval notation. You open the activity on Microsoft Teams. Then you have to do your workout on a piece of paper, work the numbers out, and after you find the right answer, you select, you write down the right answer on the using Microsoft Teams and Microsoft Forms. And let's go, let's do the work.